Okay, so if I want to find the area between two curves, just subtract the top curve minus the bottom curve and integrate that result. So if I want to calculate the area between f and g from x equals -1 to x equals, I think it's 2. Hold on. I think it's 2. Yeah, it's x equals 2. All right, so calculate the area between these two functions, between x equals -1 and x equals 2. So what does that look like? X squared plus 2 has a y-intercept of 2, and it's going to open upward. It's just a parabola. And the function 1 is just a horizontal line at 1. So what they're asking for between -1 and 2 is they're looking for the area between the two functions from -1 to 2. So they want this area right here. Okay. So do we understand what the question is asking us to find? So between these two vertical lines, -1 and -2, I want the area between those two functions. Okay.
Wait, how did you graph the second one?
So this is the x-axis. This is at y equals 1. So the function y equals 1 is just a horizontal line at 1.
Oh, look at the wrong one.
Yeah, so this is the x-axis. And that's y equals 1.
Straight line. I didn't think that
You
was
see
the
the
function.
arrows
I
in
thought
the
that
arrows.
was.
Sure.
There you go.
Okay, so how do I find the area?
F of x minus g of x.
Thank you, yep. So the area is the top area minus the bottom area, and that's going from -1 to 2. That is how you find area, yep. Rectangle. That's how we base this all around. So my first function is x squared plus 2 minus 1, all with respect to x. So instead of integrating them both separately right now, let's do a little bit of algebra or simplifying. What's x squared plus 2 minus 1? X squared plus 1. So let's just do that. So x squared plus 1 dx. So what's the antiderivative of this function?
Give me a second. It's 1/3 x cubed plus x plus c.
And when it's a definite integral, there's no plus c.
I tried.
So from -1 to 2. So what the fundamental theorem of calculus, right? F of b, capital F of b minus f of a. So it's going to be plug in the 2 and the -1. So we're going to plug in 2. That's f of b minus. Do the same thing but plug in -1.
Wait, I thought you did the bottom number first.
Nope.
Oh my gosh, I did the entire homework backwards.
So you got a negative number. So,
Yeah, so whatever your answer is, just change the sign.
so you got -3 in the answer.
Alright, so then we just gotta evaluate this out, right?
Didn't we used to do something from the bottom number first?
Maybe.
Look. Oh my gosh, I thought I was finally getting it.
That's not getting it. Anyways, alright, so these parentheses are important, right? Use these parentheses. They're not gonna hurt you, they're only gonna help you. What's 2 cubed? 8, so that's 8/3 plus 2. -1 cubed is -1. -1 times 1/3 is -1/3.
-4/3.
Instead of
Alright.
putting these together now, I'm just gonna make the work a little bit easier. I'm gonna distribute that negative, and then 8/3 plus 1/3 is 9/3, also known as 3, and 2 plus 1 is 3. So this is really 3 plus 3, which is 6. And you could have done 8/3 plus 6/3, and 8/3 and 6/3 will give you a number. And -1/3 minus 1/3, -4/3. Add them together, you'll still get 6.
Nice.
But do you see why the parentheses are important? Those of you who were doing the classwork last time, the main mistakes were people not distributing the negative, and that's why I put the parentheses in there to distribute that negative sign. Cool?
Wait, I have a question.
Yes.
So, on the top of the page you have right now,
Yes.
you see how it says like X and then there's a line and it's 2 over.
2 to -1, yes.
So what is that line?
That's just the limits of integration. It's like, yeah, it's a new notation too, but it's just this is the antiderivative, and I'm going from 2 to -1. So I'm doing one step, I'm finding capital F of X, and then the fundamental theorem of calculus says do F of B minus F of A. F of B is when you plug 2 into this, minus F of A is when you plug the lower limit into it. Yep. So this is kind of like capital F, and this would be F of B minus, and this would be F of A. The FTC. Questions? Okay. What if the curves intersect?
GG.
Oh, you're a different person. 2 weeks ago.
I lost my sanity. Go.
That's okay.
Nah, I got this. Give me a sec. I'll figure it out.
So we're trying to find this area right here.
You add them?
Add what?
That's what you do.
If I add them, I'll get.
All the stuff outside.
I would be double counting some spots because I would get that area, and then I would get this area, but double counting the middle area.
A minus B.
When you try and find I'm sure. So the line under it to the left, all that area right there. You try and find that first and double it because it's the same on each side.
So that's a strategy that I was going to kind of get to at the end, but yeah, you could do that, but still, how do I do that?
Take the
If
area
you
of the
find
whole
the area
thing.
under the curve, wouldn't you be getting the bottom of the blue curve of F of X?
So if I took the area under f of x, I would get all of this area, not
Yeah,
negative.
So wouldn't you just subtract that from B instead of doing it the other way around?
No, you still want the top function to be on top.
Wait, how do we know?
Well, yeah. So
You're
yeah,
trying to find the area inside that curve, not outside of it, right?
yeah. So I just want the area bounded between the two curves. So this area right here. This is what I want.
Which color is F and which color is G?
So g of x equals 4. That's gonna be this one, and then the x squared's got to be.
So instead of doing F minus G, when you do G minus F,
So yeah, that's not where my issue is. All right. So say I did that. So The answer is correct. The top curve is G in this case. The bottom curve is F because G is above it. But my question is, where are we going to? Because before I told you it's from -1 to 2. Here I didn't tell you where it's going to.
You would go to -2 too.
And how'd you know that?
By looking at the graph.
Because that's where they start.
Okay.
Oh, that's where they intersect.
Yes. So you need to find these intersection points. Right here, it's easy. Sometimes it's not going to be so easy. So we're going from -2 to 2. And don't think f of x minus g of x. Think the top curve minus the bottom curve.
What do you mean by top curve? Like,
Which, in this, between -2 and 2, which curve is on top?
oh, straight line?
Yes, so
Okay,
this would be the top curve.
understood. The only reason I didn't really understand is because it's a straight line. I doubt.
Yeah, I mean, at some...
It's still a curve. I get it,
Yeah, sure. And if you go outside of this, then that becomes the top curve,
but understood.
which we'll deal with that when it happens. All right, so I need to take the top curve minus the bottom curve. And in this case, the top curve happens to be called G, and the bottom curve happens to be called F. Whatever, it's just a name. And then it's the same problem. So it's going to be 4 minus x squared. All right. What do we get? Let's see. The antiderivative of 4 is, and the antiderivative of x squared is
1/3 x cubed.
from -2 to 2. By the way, now that we found the antiderivative, the integral sign is gone, right? We did that operation.
8 minus 8/3.
Oh yeah, I did notice myself starting to realize that like how you just moved the 1/3 instead of doing like x3 over 3,
Yep.
so making 1/3. I did realize myself doing that. Like it's starting to like click.
Takes a while. It doesn't happen right away.
I still do the math in my head, just like, but I have to do it like it's just like really quick.
Yeah.
To the point
You go from saying like x to the 5th over 5 to 1/5 x to the 5th.
Yeah.
And at some point, you'll go from saying x to the 6/5 over 6/5 to 5/6 x to the 6/5. Yeah. It's just
Oh shit.
takes a minute to get there. Anyways, so here we go. I need to, there's my antiderivative, there's my capital F. Now I need to use the FTC here, right? Fundamental theorem of calculus, and plug in our limits of integration. So it's from the x equals 2 to -2. Use the parentheses. So let's see, 4 times 2 is 8.
8 minus 8/3
Yes.
minus -8 plus 8/3, maybe? I don't know.
Yep. Yes. -2 cubed is -8. The double negative is going to make that a plus.
Yeah, that's. It's kind of 0.
Nope, because of this negative.
Oh, shoot.
Distribute the negative. That's going to make that a plus and that a minus. So what I'm going to do here is I'm going to do 8 plus 8 is 16. And -8/3 minus 8/3 is -16/3.
Just 5 and 1, the -5 1/3, so it's 11.
Is it 32/3?
Sorry?
I think it's 32/3. Am I wrong?
Oh, if you're turning it into that.
I'm going to have to triple 16 to get the same denominator. And I'm taking one of the 16s away, so it's really just doubling 16, which is 32. Okay, let's do that again.
Well, can't you just.
So this is really just going to be, what's 16 times 3?
48.
48. So 48/3 minus 16/3 is 32/3.
I would do that a way different way.
Okay. Your problem, whatever your answer, like you're gonna get 32/3 as an answer, and if you write that as like a mixed number, whatever, but like you won't see that in like the back, like nowhere in the book. It's rare that you'll see it in math books mixed numbers unless it's like something applied.
I would just do 16, what's the 16 divided by 3, which is 5 1/3. So you minus a 5 from 16 to 11.
Yep.
And you do 11 times 3, which is 33, but you have a minus 1. So
Yeah, you get there. That'll work. All right, so the answer was 32/3. Now, I want to bring up something that Ollie said, because you could save yourself a lot of time if you recognize this. It has something to do with functions being even or odd. Has anyone ever heard of an even function or an odd function?
Yes.
Maybe you don't know what makes it even or odd, but like, can you give me an example of a function that is even or odd?
The exponent.
Okay, yes, so like x squared is even, and x to the third is an odd function. Cosine of x is an even function. Sine of x is actually an odd function.
Is it how many times it touches the x-axis?
No.
Can you use direction?
This is something that you would have seen in pre-calc, and without giving you the definition, has to do with if you plug in a negative number into an even function, it's the same as it's the same as plugging in that same number but being positive. So what makes the function even is if this is true. So if plugging a negative value or plugging a positive value, if it gives you the same thing, then that is an even function. And if plugging in a negative value is the same thing as putting the negative value outside of the function, that makes it odd. Ignore that. That's not kind of the point. So what Ollie said is this. I originally asked you to find this area. And he said, well, can't we just find this area and double it? Does that seem doable? You absolutely could. The only thing that would change now is that we would be going from 0 to 2, and we'd have to double it, right? So if I did the whole process, I would get the same thing, but once I got to this point right here, plugging in 0 is just really easy to do. This is just going to become 0, and we just have to double that, which is exactly what we did. 8 and 8 gave me 16, and negative 8/3, double that, we got negative 16/3. So we could have just done this to get my answer and been completely correct.
I don't know if it's like the screen. It's like glitching out. It's really.
It's a little slow.
No, it's like you know when you see like TV static where it's like a bunch of like.
Oh,
it's like
you see the
that
lines?
random interval.
I think it's called senioritis. Come on. All right. So,
Give it a tab.
if you have something nice like that, it works out nicely. And by the way, this is, I forgot what I talked to this about, but say I gave you this. This function right here. Don't write this down, but just I want you to just kind of put your pencils down and think about it. Say I was going from -1 to 1, and I said, here's my function f. If I said find the area under that curve from -1 to 1. So I want this area right here.
Wasn't that for our homework?
Maybe. So this is an odd function, and if you're going from negative a to a, what's the area going to be? Well, whatever this is some number, right? Call it 7. This is the same number, but it's below the x-axis, so it's -7.
It's gonna be 0.
So it would just be 0. So if it's an odd function, then that's just going to be 0. So the bottom area kind of cancels the top area. Yep. And if it's an even function, like x squared, if I'm going from -2 to say 2, instead of going that, you can just go from 0 to 2 and double it like you did. So instead of going from like -2 to 2, that's the same thing as going from 0 to 2 and just multiplying it by 2. So that could save you some time if you recognize it. There was one class I took where we had to, not every homework, like there would be like maybe like 6 homework questions, and like every day like you two had to present one, and the next day you two had to present one, and then you two. And so a question that I had to present with my partner, he didn't do it with me, so I just did it.
Good partner.
Social movement.
No, he was a different, like, he was really smart, so he never actually had to like he picked up things quickly, so he would just do the homework like an hour before class and be like done. Like I'd have to like start it the day of, get stuck, ask someone for help, get through it, get stuck again. It's like I get there. He just got there quicker. So he's like, yeah, just go do it on the board. I don't even need to look at it. I'm sure you got it. And so then I go do the whole thing out, and then it ended up being like this area and that area all canceled out, and then at the end the answer was 0. And I didn't recognize that, so I all that work, and it took 1, 2, 3 whiteboards. It was miserable.
Really?
What?
Yeah. Well, it's all just like I'm doing like it's like a long problem, and just one. I'm not doing like 7 steps at once. I'm like, all right, those things cancel out. Rewrite it all.
Okay.
Those things combine. Rewrite it all. Distribute that. Rewrite it all. So like I was doing one little step at a time because I was presenting on it to make sure like in my mind like every little step was important.
He just comes into the board of races. He just does like this minus this.
That's what, yeah. He goes. Well, that's what he goes. He goes. Yeah. So basically, you can do it all and it checks out, but we know that it's a non-function because it follows, this property. So we're going from negative a to a, so it's just going to be 0. Okay, moving on.
And then everyone clapped. And...
No one clapped. It was just. I think they just felt bad for me.
You blocked out the closet.
All right.
People felt bad for you?
They were sitting in the class, like, oh man.
Wait, was this high school
It
or
was
college?
This was college.
This college.
Calc 4.
There's 4 of these classes?
It goes beyond that.
Oh.
There's different kinds of calculus. So most undergrads, there's just Calc 1, Calc 2, and then what they call a multivariable calculus. Multivariable calculus, a lot of schools don't get through in one semester, so they'll call it Calc 3, and then Calc 4 will be like the rest of multivariable calculus, and then they just add whatever they want to add to the course that you may have skipped over at some point.
Oh my gosh.
That's a little bit crazy.
That's nice. All right. So, anyways, find what if the top curve changes? How would we find the area bounded between the two curves? So I want the area between these two curves.
Concavity. Sorry.
That's a good word.
Is it?
So when we're talking about area between curves, it's always going to be positive, so there's no canceling out going on. But I want to find this area and that area. But what's up?
Never mind. Sorry. I'll ask a question.
But what's happening here is the top function. By the way, which one is the blue one, F or G?
Blue is F.
Okay, so the top function at first is F. But then once you pass 0, F is now the bottom function, right? So it changes. So how would we account for that change? Ignore the fact that it's symmetric and we can just find one area and double it.
It would be 0, wouldn't it, though, again?
No, because so that's true if it's area under one curve, but when it's between two curves, it's always gonna be positive. Like the idea of like negative area when you subtracting becomes positive. So we're finding like this is just an actual chunk of area. There's no negative here.
I
So
guess,
whichever
yeah.
one's bigger, you just subtract that from the smaller over, and then you add the two together. Like you do 2 equations and add them together.
Yeah. So the strategy is this. Break it up into 2 separate problems. First, find this chunk. That's going to take an integral, and you're going to have to subtract. In this case, you have to do f minus g. Then do it separately again of this chunk, and in this time, the bottom function is now f, so it's going to be g minus f in this case. And we got to find our limits. Okay. So we're going to do one piece at a time. Is this the last one, or do we got one more after this?
Oh, I guess the last.
Nice.
Nice.
Nice. Come on. I know it's May. All right, so I'm going to try to find that orange area first. So to find the area under the curve, I need to take my top function and subtract my bottom function. So my top function here is f, and my bottom function here is g, so it's going to be f of x minus g of x. From what to what, though? Where am I?
Where they intersect.
Where they intersect. So they're intersecting at 0 and blank. How would I find out where else they're intersecting?
Isn't there a thing on your calculator, the thing that showed like it was like you hit the map and you go up to like F4 and
We're not gonna let a computer do this.
well that
-1.5.
What have you done all?
Am I right though?
Yeah, you could trace it on a calculator.
Okay, it's
Yeah.
tracing. Thank you. That's the word.
Or like find intersection.
Something like that.
How do you find out where two functions cross? This should be. Not. This shouldn't be. That.
When they have the same value.
Yeah. So how do you find that? Set them equal, right? So we want to find out when they have the same value. So when does x cubed minus x equal x? How many solutions is this going to have?
No, I can think of two.
1, 2. It should have 3 if they're intersecting at 3 points, right?
It's 1, 0, and -1, right?
Nope.
It's not.
Plug in 1, see what happens.
What about 0?
0 is one of them, yes.
0, 1.5, and 0.
All right, so why don't we solve this like with some algebra here? I'm gonna get one side equal to 0 and see if I can factor. Is that cool?
Yeah,
Factor out the x.
that's valid. I'm with you so far.
So either x equals 0 or x squared minus 2 equals 0. What are you doing?
Me?
Why would that be? Why would that be?
I'm confused who's looking at you.
No, negative x minus another x is negative 2x. Because you're not multiplying. So x squared minus what equals 2? I mean, x squared minus, yeah, what squared minus 2 equals 0? So just add 2 to both sides. So x is going to be what?
Square root of 2. Plus or minus 2.
Yeah, and those are my 3 solutions. So I got 0, negative, and positive root 2. So this value here is negative root 2.
Isn't that like the same as sine?
It looks like a sine wave, but it's not, no. So now so in this orange region right here, we're going from negative root 2 to 0. Let me move this stuff over here.
That was cool.
Thanks.
No, I don't know how he does it.
I'm a math magician.
We're just a magician. Wait, could you move it over one more time? There we go.
Okay, so now I got my limits of integration here. You good?
Wait, hold
Yep.
on 1 second.
It's from negative.
Root 2 to 0.
Okay, I'm good.
So that'll get me that orange chunk. So this orange integral will give me the orange chunk. This green chunk right here, I'll just add that to the orange area. That'll give me the total area. That's going to be the integral of my top function minus my bottom function. What's my top function now? So I am going from 0 to root 2. But my top function and bottom function changed, right? X is my top function now, and f is my bottom function. So now it's going to be g minus f.
Oh, that's annoying. That's like more work.
All right, so let's see what we got here. So this first function is x cubed minus x minus g of x, which is x. And then the other one, g of x is x minus f of x, which is x cubed minus x. Before I do the antiderivative, I'm going to simplify here. Negative x minus x is negative 2x, right?
I'll say.
Negative x minus x.
Yeah, there was
Everybody
2x. So
was
it's
like,
really-
huh?
What?
Everybody was like, huh?
I need to hear it again. That's all.
Yep. And then here, this is where you guys gotta be careful. This is why the parentheses are important. Distribute this negative. That's gonna give me a negative x cubed and a positive x.
Yeah.
So what is x plus x?
2x.
Perfect. And then we have a minus x cubed. Okay. Now what do we do?
You know.
So you plug in now for both functions.
So you're gonna plug in 0 and negative root 2?
No, you have to do the integration.
We never integrated. We gotta do that first. What's the actual? All we were doing simplifying. Now we actually integrate. And what's the antiderivative of this guy?
1/4 x squared 1
Yep.
minus x squared.
So it'd be 2x squared over 2, and the 2's, like you said, are gonna divide out. So it's just x to the second. And that one, we're just running from negative root 2 to 0. What about the next function? What's that function's antiderivative?
2/3 x squared. No, sorry, x cubed.
X squared, right? Minus 1/4 x to the 4th. And that one's going from 0 to root 2. All right. I know we're plugging in a square root thing. It's going to be nice because what you're plugging into is an even power. So you'll get nice numbers here. Give it a try. See if you can evaluate this guy in orange and this guy in green. And see if we all can get close to or exactly right the answer.
Zero to the first one and negative, I mean,
That's wild.
I know.
Maybe you're up.
So how do you find zero for the second one?
You got, so like when you sign up with an S running
When I said this stuff.
that's why.
Yeah, I was thinking like, okay, zero for the first one and square, so I like. No, I mean, it's trying to like. Yeah, so this is.
Yeah.
So
Or like,
I just want to have zero.
like we just handed sitting there.
Yeah, I
and
run to the last
something.
That's right here.
You have to do them in two different sections.
Wait, so you plug in the top one first, not the bottom?
Yeah. Yep. So for the first one, you're plugging in 0 and then negative root 2. On the second one, you're plugging in root 2 and then 0.
Then you add.
A laboratory.
Wait, there's some more. I have a
Sorry.
question. Not around that. So like,
I know.
like Emma and I have to take an entrance math exam. So if we like score like passing calculus, what's next? Do I have to pass
Yeah,
calculus?
what about
Sure.
like a calculus already and then negative?
So should we just fail this one and take calculus again?
Sarah, what's the
You pass or you don't?
Cause then we.
So I had one girl tested into Calc 3 and failed it. So like you shouldn't skip Calc 2.
No, that's not what I'm saying. I'm saying, should we, if we pass the exam and we go into Calc 2,
Yeah.
like, is that good, or should we, like, kind of purposely fail to then take Calc again, like, since
I would
it's
say
kind of a messy year?
do your best, and if you think you need, and then they tell you to take Calc 2 and you still want, and you think you should take Calc 1 again, just like tell them I'd rather take Calc 1 again. They won't say no because like that's just more money for them.
I took my calc placement test. It was not fun.
Yeah.
But I
Was
got
that hard?
Like don't assume now that like don't assume like oh I'm just gonna
I got a
pass
39 out of 32 on it.
A 39 out of 32.
A 29.
So,
So you only got
Be
3
quiet.
points off.
that's what I'm.
Yeah. And you needed a 22 to get into calc 1, which is the highest one you can place it.
Yeah, it's rare that a school is gonna place you into Calc 2, even if you've taken AP Calc because I don't know about like every school in the world. Like I think our AP Calc pretty solid, but like from professors I've talked to, like kids will come from AP Calc and like, don't really do well. So like it doesn't really mean much if they're taking Calc in high school. Like they need to take Calc in college and then they just like good friends.
So you would suggest we
pre-calc is
take
really
calc in college?
Yeah, I mean, especially all you taking. This is just calc advanced. I don't think any of you will get to not take calc 1. We'll be able to skip calc 1.
Okay.
What would this be considered calc 1?
Yes, just calc one.
No, not the point
This
of this
is
conversation. This
intro to
conversation is
Yeah,
helpful because I would do the same thing as But I just said, what was the point of like, what's the point of taking this readiness exam if they're gonna make us take it again?
Well, you might test in the pre-calc. You might not test in the calc.
Oh my god.
Yeah, that'll probably happen.
I had a girl.
Where are you going?
No,
I
I'm
had to
being
take pre-calc
serious.
freshman year after taking calculus here.
Yes, it does.
That's probably gonna happen.
Oh my god.
And she kicked
Yo,
butt. She
everyone
was
plays
like,
C
real
for
strong.
calc.
I think I would like benefit from that, cause like, I think I need some more practice with like the older stuff.
And it'll be so much easier the second half through. No question.
Mhm.
And then people in the classroom are gonna get stressful and hating life and like anger all the time.
And
And
I'll
then
be
you'll be,
like, I got
and
this.
then you'll be that person in the class like,
I didn't trust that. I didn't do it.
Who just?
he just told you what to do. Just
Yeah,
Wait, hold on. No one.
it feels really good when you're that kid in the class.
I can't wait to be that kid. I also am not being that kid right now because having
Yeah,
a
Terry.
kid is like
Let's go. Let's go. Let's hear it. Let's right here. Tuesday.
Yeah,
Wait, what did you
I
get for
got
this
you,
one?
like,
I just always got one answer.
Alright, Terry, you guys are supposed to be finishing.
I know this is zero.
I don't remember anything. No, I don't remember anything.
You always do the
Yeah.
Oh, it's all minus?
These are minus in
the
this
front
section.
yeah.
I don't know, they're good together.
Okay.
Alright, half of us are working with the other half. We're gonna be working on this
That's okay.
a little
Yeah, so what's different?
quieter. A little quieter. Turn that 10 down to like 4.
Yeah, yeah, I know.
4. It's gotta be nice because they're in a super like them by themselves. It's like negative root 2 squared is just cute.
I'm trying to do this in my head.
And then
It's never like
this one for the
this negative
first number, and I got I got a decimal. I got 1.82.
The whole thing?
I got negative.
Zero's gonna be 0.
Yeah.
So you just have
Okay, so
negative
then
root
you
2.
add
Yeah,
two.
yeah,
Minus zero.
And so then it was just that.
I don't know what the exact number is, but
Negative 3 minus or plus something else.
2.2.
I should do it.
2.82.
So is 1/4 times negative?
I just don't.
No, yeah, I put this into my calculator, so.
I'm just like.
That's what my calculator
Like,
was.
I knew how to actually
Yeah.
put it in there. I just.
No, yeah, you just want to.
Yeah.
oh no,
There's just like.
no. Hard no.
So,
That's the
okay,
next one.
so 2 times 2 is 4 times 2 is equal to 16, divided by 4 is equal to 7 or 4, so it's gonna be minus 4.
Mr. Morgan, can you check this?
Four.
I didn't do this part
I
yet.
think
Yeah, so that's gonna be 4.
Yeah, Liz.
I'm not talking about
Yeah.
4 either.
So square root of 2 squared. No, I got my license. 2.
Oh, I didn't do
I
this.
know,
I
think you're gonna.
So then you got 16.
Like
Yeah.
in
You have
first
six.
grade, I can use
First,
It's only talking about routes. And then so you have.
Yeah, I
so
got it.
minus 1 and then
Now, you're
So
gonna
like,
just have.
When is it resets? Like the first?
so minus
First.
2.
Either that or
So
one.
minus 3.
Oh, a year after you get it.
I'm not sure.
But I didn't.
But I gotta go.
It should always be positive.
So what about it?
Oh, so you keep on
It
track.
should always be positive. Did you plug in the 0 first and then negative root 2 second, and then you don't always be negative 4.
What is it, like a John? Oh,
Mr. Mario, can you check this?
It's a motorboat.
I think.
Is it like a seven?
Yeah.
No, I got a nice number.
A nice
I
number.
got a 1.
We're gonna go.
So we're just gonna take it out.
Okay, well, I got 4.
I think that's what I got.
It might have been. What'd you get on this?
We got boat rides too, so we can go like 40.
Oh my god, I have a
You add.
It's so much fun.
Me and my dad used to go ATs.
I was close with
I do. 40's a high.
You go, I know. People don't eat a lot.
We used to catch them out of the.
Well, when you have time, you go back to the
Thank you.
Okay, and all we have to do is plug in the math for
I know.
those.
I was
So, like,
like,
you gotta ask
I
them.
number.
What?
For that other one.
I got a nice shape.
I got a nice number for the first half. Mr. Florio, I'm getting a nice number for the first half, but I keep
You probably forgot to turn on the app.
for this I'm not.
So that's something wrong on that.
Can you see if I'm plugging this to my calculator right, or if I'm using this?
Probably it's not your
Probably just let him.
You can use the calculator. The numbers are
There's a pile of rocks with like some measurements.
Mr.
Where?
No, it's
James River?
yeah, closer to
Like
So
under the bridge?
let's choose
No, it's not under the bridge. It's out.
Here, it should be. Is it the race?
Is
it the Highlands?
No, I don't think so.
You fish, Jack? Have you
And then what's the
been
fourth four?
So
One
one
plus
to
four.
go.
That's what, yeah, that's what
Fresh
I
and
said,
salt.
yeah.
There was the day this spring.
Yeah.
Wait, I got 1.5.
No, it's not.
What do you do next day?
Emma, I got 1.5 for this.
It's supposed to be.
And then
You made a
negative
mistake with
1.5.
negative. There's a double negative that you missed.
I give up. Plus 1.5. I got a 0.
I just like, there's
And
nothing
just a double
we can
negative
spend
somewhere.
Yeah. Going
Yeah,
there.
you didn't get 0.5. I got 1 minus negative.
I got
One minus negative.
Oh, I get 1
I
plus.
got
See if I.
Why is it
Wait,
one
I
minus
don't
negative?
Yeah.
I have a brand new board.
That's like it's like a weird number because I have to.
No, it's not.
I just thought it was
So it's either- I have a big caster, but it's shot. I left my fishing pole in the car last summer and I had to make cast. No. One of the ones.
You know, like the auto guy?
The what?
The guy who's like
So
the
I
auto,
was like,
like the car guy?
big caster.
He's one of the cyclic.
So I
Yeah,
went and I grabbed the.
he has a plane run there.
I grabbed the bait caster, went out to fish, and I like tried to cast it.
All of
It wouldn't do anything.
All right, so let's do it together. Okay. So guys, look up on the board, please.
Really?
We're not looking on the board, we go like all the time.
You guys looking? All right. Now we're looking? No. Okay. All right, so let's do it. So if I plug in the top limit at 0, can I just, we all agree that when you plug in 0, it's going to be 0, right?
Yes.
So it's going to be 0 minus, when I plug in negative root 2, that's the fourth power minus negative root 2 squared. All right, so this is my f of a minus f of b. We just did that one really easy because we knew it was 0, right?
Yeah.
Okay, I'll do the green one in a second, but we'll just stick with the orange one. Okay, so this is going to be 0. I'm just going to put a negative here. What's negative root 2 to the fourth? It's going to be positive because it's an even power, right?
4, right?
It's an even power, so it's going to be positive. We agree? That part? All right. So, I mean, okay, so when you raise to the fourth power, I guess you're squaring it twice. So if you square it once, you get 2. If you square it again, you get 4. So it's going to be 4. Or you can just do 2 to the fourth, which is 16, and the square root of 16 is 4. Okay. So this is going to be a positive 4. What's a fourth times 4?
1.
All right. So we have 1. Negative root 2 squared is just 2, right? It's going to be positive, so it's going to be minus positive 2, right? So minus positive 2. Now this negative is still here.
Yeah. So it goes to 3. No, it goes to 1.
You said
It's 2 minus 1.
you distribute the negative.
Yeah, so it's negative 1 plus 2.
So it'd be negative 1 plus 2. 2 minus 1 is
Oh.
1. Okay?
Yeah.
I guess I could have gotten rid of that at that point. Okay, do the same thing with the green area. Now I'm going to plug in root 2 minus 1/4 of root 2 to the 4th minus plug in. If we plug in 0, we all agree I'm going to get 0, right?
Yes.
All right, so I'm going to.
Sorry, can you get rid of it because it's minus 0, it's not in the beginning of it?
Sure, bye. So now it's just going to be plus whatever it comes out to be. So the square root of 2 squared is 2. And this is 1/4 times, what's the square root of 2 to the 4th? 4. So that's just going to be 2 minus 1, which is 1. So we have 1 plus 1 equals 2. So that whole area was just 2.
Copy.
And if we used the symmetry that Ali mentioned before, we could have just zoomed in on this area right here, which is this function right here, and just doubled it. So if I just took this 1 right here and doubled it, I would have gotten 2. That make sense? Yeah, I think I said it last time. Now that I think about it, that's something that all the physics majors always knew what to do. Those
physics
those
Dr. Love.
Dr. Love. Okay, so the homework's posted.